Hi friends, today we are going to discuss the analytical treatment of parallelogram law of vector addition. OA is a P vector and OB is a Q vector, represents the adjacent side of a parallelogram. The theta is the angle between the two vectors. Form a parallelogram with these two sides as adjacent sides. Form a parallelogram like this. This OC vector represents the resultant of this two vector. Draw the perpendicular line from C. It meets OD, extended OD at D. Now this angle also theta. The resultant direction can be taken as alpha. Now we are going to discuss the resultant magnitude and resultant direction. Now in triangle this ADC, in right angle triangle ADC, sin theta must be equal to CD by AC and cos theta is equal to AD by AC. Here AC is almost equal to the Q vector, that is why sin theta is equal to CD by Q vector modulus and cos theta must be written as AD by Q vector modulus. Now this CD can be written as Q sin theta and this AD can be written as Q cos theta. Now I point out this in the diagram. Here this is Q sin theta and this part is Q cos theta. Now we are going to consider the bigger right angle triangle ODC. So in right angle triangle ODC, their resultant OC square is equal to OD square plus DC square by Pythagoras theorem. Now this OC square is R square, this is equal to OD square, that is P plus Q cos theta the whole square, then DC square is Q sin theta the whole square. Now the written as R square is equal to P square plus 2PQ cos theta plus Q square cos square theta plus Q square sin square theta. Now this Q square is common, we will take it outside. P square plus 2PQ cos theta plus Q square into sin square theta plus cos square theta according to the identity 1. So R square become P square plus Q square plus 2PQ cos theta. So R resultant magnitude can be written as root of P square plus Q square plus 2PQ cos theta. This is the resultant magnitude. Now we are going to discuss the resultant direction. According to the resultant direction in right angle triangle ODC, tan alpha is equal to opposite side CD by adjacent side OD. So here Q sin theta by P plus Q cos theta, that is tan alpha. So the resultant direction is tan inverse Q sin theta by P plus Q cos theta. So this is magnitude of resultant and this is the direction of the resultant. Now we discuss the special case of the theorem. First case 1. Now we consider that this P vector and Q vector. Here the Q vector lies on the side of P vector. Now the theta will become 0. So cos 0 become 1. Now the resultant magnitude should be root of P square plus Q square plus 2PQ cos of 0, cos 0 1, root of P square plus Q square plus 2PQ. This can be written as the identity P plus Q the whole square. So the resultant should be P plus Q. That is, if the two vectors lie on the same side, the resultant should be sum of the individual vector. Now second case, case 2. If this q vector lie opposite to the direction of p, then theta will become 180. So here cos 180 will become minus 1. So now the resultant magnitude should be p square plus q square plus 2pq cos of 180. This can be written as p square plus q square plus 2pq minus 1. So this can be written as p square plus q square minus 2pq. This use the identity p minus q the whole square, it become p minus q. This is resultant magnitude of this. In both cases, resultant direction is tan inverse q sin 0 by p plus q cos 0. Sin 0 0, totally tan inverse 0, the answer is 0. For here also alpha is equal to tan inverse q sin 180 by p plus q cos 180. This also sin 180 is equal to 0. So this also become tan inverse 0. So this alpha is equal to 0. So in both cases magnitude is p plus q, direction is 0. Here also magnitude is p minus q, direction is 0. Now we discuss the third case, case 3. Thus p vector is perpendicular to q vector. That is the angle between them become 90 degree. So sin 90 is equal to 1 and cos 90 is equal to 0. So the resultant magnitude should be root of p square plus q square plus 2pq cos of 90. Cos 90 0, the answer will become p square plus q square. So the resultant direction alpha must be equal to tan inverse q sin 90 divided by p plus q cos 90. The sin 91, cos 90 becomes 0. The answer will become tan inverse q by p. That's all for today's video.